Imagine being in a remote village, far from the city, surrounded by nature's tranquility, yet enjoying streaming of your favorite shows and holding important video chats. How? Not with regular internet, but thanks to mobile broadband. Mobile broadband, in simple terms, provides wireless high-speed internet access through radio towers. It lets you connect to the internet wherever there's cellular service, similar to how your phone works. So come along as we dive into the fascinating world of mobile broadband. Mobile broadband is the marketing term for wireless internet access via mobile, cell, networks. Access to the network can be made through a portable modem, wireless modem, or a tablet/smartphone, possibly tethered, or other mobile device. The first wireless internet access became available in 1991 as part of the second generation, 2G, of mobile phone technology. Higher speeds became available in 2001 and 2006 as part of the third, 3G, and fourth, 4G, generations. In 2011, 90% of the world's population lived in areas with 2G coverage, while 45% lived in areas with 2G and 3G coverage. Mobile broadband uses the spectrum of 225 MHz to 3700 MHz. Description: mobile broadband is the marketing term for wireless internet access delivered through cellular towers to computers and other digital devices using portable modems. Although broadband has a technical meaning, wireless carrier marketing uses the phrase mobile broadband as a synonym for mobile internet access. Some mobile services allow more than one device to be connected to the internet using a single cellular connection using a process called tethering. The bit rates available with mobile broadband devices support voice and video as well as other data access. Devices that provide mobile broadband to mobile computers include PC cards, also known as PC data cards, and Express cards. Mini PCI and Mini PCI Express cards that are integrated into the laptop. USB and mobile broadband modems, also known as Connect cards. Portable devices with built-in support for mobile broadband, such as laptops, smartphones/tablets, PDAs, and other mobile internet devices. Internet access subscriptions are usually sold separately from mobile service subscriptions. Generations. Roughly every 10 years, new mobile network technology and infrastructure involving a change in the fundamental nature of the service, non-backwards compatible transmission technology, higher peak data rates, new frequency bands, and / or wider channel frequency bandwidth in Hertz, becomes available. These transitions are referred to as generations. The first mobile data services became available during the second generation, 2G. The download, to the user, and upload, to the internet, data rates given above are peak or maximum rates and end users will typically experience lower data rates. WiMAX was originally developed to deliver fixed wireless service with wireless mobility added in 2005. CDPD, CDMA 2000 EVDU, and MBWA are no longer being actively developed. In 2011, 90% of the world's population lived in areas with 2G coverage, while 45% lived in areas with 2G and 3G coverage and 5% lived in areas with 4G coverage. By 2017, more than 90% of the world's population is expected to have 2G coverage, 85% is expected to have 3G coverage, and 50% will have 4G coverage. A barrier to mobile broadband use is the coverage provided by the mobile service networks. This may mean no mobile network or that service is limited to older and slower mobile broadband technologies. Customers will not always be able to achieve the speeds advertised due to mobile data coverage limitations, including distance to the cell tower. In addition, there are issues with connectivity, network capacity, application quality, and mobile network operators' overall inexperience with data traffic. Peak speeds experienced by users are also often limited by the capabilities of their mobile phone or other mobile device. Subscriptions and usage. At the end of 2012, there were estimated to be 6.6 billion mobile network subscriptions worldwide, 89% penetration, representing roughly 4.4 billion subscribers. Many people have more than one subscription. Growth has been around 9% year-on-year. Mobile phone subscriptions were expected to reach 9.3 billion in 2018. At the end of 2012 there were roughly 1.5 billion mobile broadband subscriptions, growing at a 50% year-on-year rate. Mobile broadband subscriptions were expected to reach 6.5 billion in 2018. Mobile data traffic doubled between the end of 2011, 620 petabytes in Q4 2011, and the end of 2012, 1280 petabytes in Q4 2012. This traffic growth is and will continue to be driven by large increases in the number of mobile subscriptions and by increases in the average data traffic per subscription due to increases in the number of smartphones being sold, the use of more demanding applications and in particular video, and the availability and deployment of newer 3G and 4G technologies capable of higher data rates. Total mobile broadband traffic was expected to increase by a factor of 12 to roughly 13,000 petabytes by 2018. On average, a mobile laptop generates approximately 7 times more traffic than a smartphone, 3 GB versus 450 MB/month. This ratio was forecast to fall to 5 times, 10 GB versus 2 GB/month, by 2018. Traffic from mobile devices that tether, share the data access of one device with multiple devices, can be up to 20 times higher than that from non-tethering users and averages between 7 and 14 times higher. It has also been shown that there are large differences in subscriber and traffic patterns between different provider networks, regional markets, device and user types. Demand from emerging markets has fueled growth in both mobile device and mobile broadband subscriptions and use. Lacking widespread fixed-line infrastructure, many emerging markets use mobile broadband technologies to deliver affordable high-speed internet access to the mass market. One common use case of mobile broadband is among the construction industry. In 1995, telecommunication, mobile phone, integrated circuit, and laptop computer manufacturers formed the GSM Association to push for built-in support for mobile broadband technology on notebook computers. The association established a service mark to identify devices that include internet connectivity. Established in early 1998, the Global Third Generation Partnership Project, 3GPP, develops the evolving GSM family of standards, which includes GSM, Edge, BOOCMA/UMTS, HSPA, LTE, and 5G NR. In 2011 these standards were the most used method to deliver mobile broadband. With the development of the 4G LTE signaling standard, download speeds could be increased to 300 Mbps per second within the next several years. The IEEE Working Group IEEE 802.16 produces standards adopted in products using the WiMAX trademark. The original fixed WiMAX standard was released in 2001 and mobile WiMAX was added in 2005. The WiMAX Forum is a non-profit organization formed to promote the adoption of WiMAX-compatible products and services. In use, but moving to other protocols. Established in late 1998, the Global Third Generation Partnership Project 2, 3GPP2, develops the evolving CDMA family of standards, which includes CDMA1, CDMA 2000, and CDMA 2000 EVDU. CDMA 2000 EVDU is no longer being developed. In 2002, the Institute of Electrical and Electronics Engineers, IEEE, established a Mobile Broadband Wireless Access, MBWA, working group. They developed the IEEE 802.20 standard in 2008, with amendments in 2010. Edholm's law in 2004 noted that the bandwidths of wireless cellular networks have been increasing at a faster pace compared to wired telecommunications networks. This is due to advances in MOSFET wireless technology enabling the development and growth of digital wireless networks. The wide adoption of RF CMOS, radio frequency CMOS, power MOSFET, and LDMOS, lateral diffused MOS, devices led to the development and proliferation of digital wireless networks in the 1990s, with further advances in MOSFET technology leading to rapidly increasing network bandwidth since the 2000s. Mobile broadband utilizes 3G, 4G, and 5G mobile signals to deliver a reliable internet connection for homes and businesses, similar to smartphone connections through a SIM card-enabled device. It's a viable alternative to fixed-line broadband, offering connectivity options for many households where fixed-line broadband isn't viable or for businesses that need a backup connection. This blog explores how mobile broadband works, the many different types available in the market, and the advantages and disadvantages to help determine if it meets your internet needs. How mobile broadband works. Mobile technology applies the same technology that connects your smartphone to the internet while you're on the go. Your device will access 3G, 4G, or 5G data networks based on location. You can use USB dongles and mobile broadband routers to connect your device or directly insert a SIM card into your cell phone, laptop, or tablet and use the mobile hotspot feature. The best method depends on your internet service provider, data plan, and device. Before using mobile broadband services overseas, check with your provider regarding roaming fees and data restrictions. Different ways to access mobile broadband internet. Mobile dongle, a small USB stick which provides instant internet access once inserted into a laptop's USB port. It can only be connected to one device. MiFi Pocket Wi-Fi, a small, portable, battery-operated device that functions like a home router that can be used anywhere. Tethering, some network providers offer tethering on their SIM plans, enabling you to use your smartphones as a mobile router to create a personal hotspot. Data-only SIM, a SIM card that can be used in tablets and newer laptops with a SIM slot for mobile data without a phone number. Mobile broadband router, a router dedicated to mobile broadband services ensuring fast connectivity, Wi-Fi access, Ethernet ports to connect to your wired LAN network, and firewall and VPN services. The speed of your mobile broadband is affected by the package, location, and device used. Signal strength varies by region, some devices only work with specific networks. In 5G areas with a 5G plan, users can access ultra-fast mobile internet speeds up to 1000 Mbps, surpassing some fixed-line broadband packages. However, achieving top speeds may be limited until full 5G infrastructure is in place, as some providers have 5G plans that estimate a maximum download speed of around 100 Mbps. 4G is the previous generation of mobile network technology, though it is incorporated into the advancing 5G network. A 4G-enabled device with a suitable plan in the correct location could achieve a maximum bandwidth download speed of 150 Mbps, although providers recommend a more practical speed of 30 Mbps. In comparison, 3G offers a maximum speed of 7.2 Mbps, yet connectivity may need to be stronger in areas with limited signal coverage. The download speed you receive is determined by your location and the device you are using. Mobile broadband grants internet connectivity via cellular networks, whereas Wi-Fi is a wireless local area network, LAN, enabling devices to link to a local router for internet access. Unlike Wi-Fi, mobile broadband isn't constrained by specific network locations. With advances in 5G technology, what are the advantages and disadvantages to switching to a high-speed internet mobile broadband service over a fixed-line internet connection? Advantages. Delivery time. With a mobile broadband connection, you no longer have to wait for an engineer to install a fixed landline or complete a site survey to determine how to route the internet service to your building. Order a mobile broadband router, insert a SIM card, and away you go, enabling you to get connected to the internet within 24 hours. Choice of providers. With a mobile broadband connection using a multi-network SIM card or a dual SIM card router, you can choose the best mobile telecommunication network and signal for your location. If one mobile network is slow, you can automatically connect to a better mobile wireless broadband network to ensure the best speed and latency. Support for a range of services. A mobile broadband service from IoT can support a range of services, including a fixed IP address, VoIP, video conferencing, cloud, and VPN, virtual private network, services, to ensure you can securely connect to critical services wherever you are located. Disadvantages: shortage of mobile broadband providers. While a diverse range of mobile broadband packages are available at different price levels, the number of providers remains limited. This is especially noticeable compared to the higher number of traditional wired home broadband providers. Download limits: the download limits on mobile broadband deals are usually less generous than those on home broadband packages. However, they fare well compared to internet access packages on mobile phones. Smartphones use the same 3G network as mobile broadband. Therefore, opting for a mobile broadband deal offers better value than choosing an internet package for a mobile device. Download speeds: where you are located can affect your mobile broadband speed and bandwidth. A mobile signal is often better outside than within an office, as walls can interfere with the network signal. In addition, certain areas of the country may not have access to 4G or 5G networks, with 3G as the only viable option. Because of existing network constraints, 3G networks tend to be slower than traditional wired or cable broadband when downloading files. The highest download speed you may encounter is usually approximately 7.2 MB. Some providers plan to trial download speeds of 14.4 MB in major cities, so watch for further developments. Thank you for watching this video.